Hi everyone, welcome to this video. Today I'm going to show you how to build an AI chatbot using LangChain, Claude and PineCone. And this chatbot will run locally on your machine and interact with your own data to provide intelligent responses. So whether you have a collection of documents, books or any other type of text data, this tutorial will help you leverage AI to interact with that data effectively. And this is very useful in particular, for example, for customer support chatbots or a chatbot to train new hires. So in this tutorial, we'll be creating a Retrieval-Augmented Generation application, which is perfect for scenarios where you have a lot of text data and you need to ask specific questions, but the database is so big that you cannot enter it in one prompt. So the chatbot will use your data sources to retrieve the relevant pieces of information in order to provide an accurate and relevant response. And this way also avoiding the common issue of AI hallucinations. We will be building this application in Python using the LangChain framework, a PineCone vector database, and Anthropic's Claude large language model. If this project sounds complex to you, don't worry, it is easier than you think. I'll guide you through every step, starting with preparing your data, turning it into a vector database, and then we'll query that database for relevant information. And finally, we combine everything to build a cohesive chatbot. If that sounds good to you, let's get started. Before we dive into the code, I want to take this moment to explain to you the RAG approach in a bit more detail. As I already mentioned before, RAG stands for Retrieval-Augmented Generation, meaning that you have a large database of text which you split into smaller pieces, and then you use a large language model to retrieve the relevant pieces of text, and then they are passed together with your initial question as a prompt to the large language model, which then returns a relevant response. In this overview, you can see all the steps that we will perform to set up this Retrieval-Augmented Generation approach. We will start from a set of PDF files and extract their textual data. Then we will go ahead and split all the text in smaller pieces. These pieces are then embedded in a Vectorstore. What is a vector actually? Well, a vector is a numerical representation of your text, meaning that we will transfer words into numerical values. You can think of a vector actually as kind of the coordinates of a multidimensional space, so a bit like an XYZ value. These vectors can be used by the large language models to perform a semantic similarity search. Semantic meaning that the similarity is based onto the semantic meaning of a word. So for example, if you have a vector of the word dog and the vector of the word cat, those two vectors will be quite similar in the semantic search algorithm of the large language model. While if you would compare dog with apple, they would be way less similar than dog and cat. So once we have embedded all our pieces of text into vectors and store them into a vector store, for which we will use PineCone, then we can go ahead and use that vector store for queries. How does that work exactly? Well, when a user asks a question, the first thing that happens is that the question gets embedded as a vector itself. Then the first large language model comes into play. This large language model will retrieve relevant pieces of information from our vector store by comparing the vector of our user question and the vectors of our database. And as I just explained, by semantic sequence similarity, we will find pieces of data that are highly similar to our question. Then these relevant pieces of information are merged together with our initial question into a prompt, and that prompt plus relevant information is sent to another large language model. For this, we will use Claude by Anthropic, and this large language model will then interpret the question and the information and produce a highly accurate and relevant response. So that is the overview of the RAG approach that we will implement here. This is really the basic version of RAG, the vanilla RAG, as being called in the software development space. Of course, you have more advanced techniques to enhance like the retrieval. But I won't go into depth in that for this tutorial. If you would be interested in learning more about this, please leave that in the comments below. So with that being said, we can finally go ahead and dive into our code. I have created a Jupyter notebook on Google Colab that I will share with you in the descriptions below, so you can go ahead and try out the code yourself and use your own data to build your own custom AI chatbot. So first of all, here again the overview that I just explained to you. And in the first code block, you will find the required dependencies that you need to install to be able to run this code. As you can see, most of the dependencies are regarding LangChain, which is the framework that we will use to build this AI chatbot. So first of all, we will load the PDF files. In this example, I have downloaded two scientific articles about immunology that I will use during this tutorial. So this is an example of one of these articles. As you can see, an article contains quite a lot of pages and text, which we'll use to retrieve information to answer the query of the user. Okay, so what I have here is a directory loader from LangChain. So LangChain provides us with a lot of different tools to parse data. One of them that I really like is the directory loader, and the reason that I like it is because you can load very efficiently all the PDF files that are located within one folder. So usually I store my PDF files in a data folder, and then using this command, I can load all the files that end with PDF. Of course, if you have Word documents, it's perfectly possible to load them as well. So we define our loader, and then with the load function, we are able to read our PDF files, as you can see here. So if we take a look at the data variable, we're able to see that the full article was stored in here. And if we check the length of our data object, we can see that we have 2 documents loaded, which is indeed the number of documents that was saved in my data folder. Also, we can take a look at the number of characters in this document, and we can see that the first article contains almost 160,000 characters. So this really shows that the document would be too large to put into a large language model as a prompt itself, for 2 reasons. First of all, that some large language models, they don't allow such large data input, although the latest models do. And secondly, you are charged by the number of tokens or words that you enter into a prompt. So the larger your input, the more costly it will become. So that is why it's highly recommended to only input smaller pieces of text. And that is precisely why we will perform step 2, the text splitting. Again, we will use a tool that is built by LangChain, the recursive character splitter. And this splitter has some parameters that you can play around with, such as the chunk size and the chunk overlap. The larger your chunk size, the larger your pieces of text, obviously. And usually it's a good idea to play around a bit with the sizes of the chunks to see whether your results get better or worse. I usually start with a chunk size around 4,000 tokens and with an overlap of 100 tokens. Meaning that there will be a slight overlap between the different pieces of text. Okay, we can then run our text splitter. And if we take a look at the chunks, we can see that we now have a document object, which is specific for LangChain, that has different pieces of text that originate from our original article. And as you can see here, it's way smaller than what we had initially. So this is, for example, one chunk of text, and here you can see that we have 73 pieces of text from our 2 initial documents. And if we take a look at the size of the first text piece, then we are indeed around 4,000 characters. So we have now reduced our 2 documents into 73 pieces of text that we will now store in our Vectorstore. So before we're able to run this code to build up our Vectorstore, we will need to create a Vectorstore on PineCone. You can also use local vector stores for this. For example, you can use Chroma to build a vector store on your local machine. However, I like to use PineCone because if you want to later scale your application, then it's already serverless in the cloud, and it then allows you to scale easier. It's also a very fast and accessible database. And what is really nice is that you can build quite a lot of big vector stores on there for free already. So let me walk you through the process of building a new vector store on PineCone. First of all, you of course will need to create an account on PineCone. And once you have done that, you will have this management console where you can see your vector stores. And to create a new vector store, you can click here on the right on Create Index. And then you can give your vector store a name. And then the most important thing here is to set the dimensions of your vector store correctly. The dimensions, they depend on the embedding model that you use. In our case, we use the Amazon embedding model, which has a vector size of 1536. You can see here that other embedding models have other dimensions, so be careful in setting the dimensions here. Then the other options here I will leave as default. I will use the AWS cloud provider and the region in US East 1. And then you can go ahead and create your index. I already set one up for this tutorial, so I won't create this one for now. So then we can take a look at the next piece of code. So in this code block, we will do two things. First of all, we will load our embedding model. As I just mentioned, we will use the Amazon embedding model called Titan. And we can access this model using AWS Bedrock, which you can call with the Boto3 package. This is the command that you need for this. So first of all, you need to create a Boto3 client called Bedrock Runtime. We will do this in the US East 1 region. I prefer to use this region because it has the most and latest versions of LLMs available, but they also become accessible in other regions. So take a look at the AWS console to see which models are available where. And then you need to pass your AWS access key and secret access key. These are my temporary access keys and secret access keys, so don't bother trying them out. They will be deprecated by the time that I release this tutorial. And then here we can load our Bedrock embedding model with the Bedrock embeddings function. We define here the model ID and our client that we just created. And the reason why I use Amazon Bedrock for this is because not only the embedding models are available here, but also all the other large language models, and that makes it just very convenient to use Bedrock client because you can choose whatever LLM on there and everything is built at AWS level, so you don't need all the different APIs of all the different providers. So let me quickly take you to the Amazon Bedrock console. Of course, you will need to create an Amazon account for this. And when you're then logged into your account, you can go to Amazon Bedrock. And one important thing here is that you need to request access to the models. So let's take a look at that. If you go in the left menu, you can get an overview of all the different models that are provided by AWS. So as you can see, we have the Anthropic models, the Claude models, but also Llama from Meta is on there, Mistral, and of course the Amazon models itself. And to request access, you can go on the left menu all the way to the bottom to model access. And here you get listed all the different Amazon models. And to request access, you can go here on top to modify model access. And then you can select the model that you want to request access to. So make sure you have access to the embedding models and also to the cloud models. Okay, so that brings us back to our Jupyter notebook. And in the next part of creating and building a vector store, we will now need to load our documents into the PineCone vector store that we just have created. And we can use this again using a package created by LangChain, the PineCone vector store package. And here we can call the from documents function. And this function requires 4 inputs. First of all, our chunks, so our pieces of text that we have created from our original articles. Then our embeddings model, which we have loaded here. Then the name of our vector store, of our index, which is the one that we created in the PineCone console. And then our PineCone API key. If we now run this piece of code, we should be able to fill our vector store with our documents. However, we have an error message here. It's mentioning that we haven't specified our API key. And the reason for that is actually because we do not need to specify it as a parameter in here, but we need to define it as an environment variable. So to do that, we can do os.environ, and then we can set a PineCone API key and copy paste this key here. Again, I will change my API key after making this tutorial. So now we should be able to run this code, and indeed everything is loading. So first the embedding model would be loaded, And then the chunks of text that we have created will be loaded into our PineCone vector store. And we can actually see this in PineCone itself. So this is the vector store that I have created. And as you can see here, before it was at 0, but now we have 73 vectors in there, which, if you recall, is exactly the number of chunks that we have created, as you can see here. Okay, so now we have basically everything set up. We have loaded in our articles, we have split them into smaller pieces, we have embedded those smaller pieces of text into vectors and loaded them into a vector store. And now we can go ahead and use that vector store in combination with a large language model, a Claude model from Anthropic, and using this combination of a vector store and the LLM, ask questions to our model. To accomplish this, we will use the next pieces of code. So first of all, we will load in our vector store from our PineCone vector store that we have created before. And for this, we can use, again, a module that is provided by LangChain, the module called PineCone Vector Store. And here we need to provide the name of our index, so the name that we gave our vector store, and the embedding model that we used before. So we can run this, and that brings us to our next piece of code. So basically, we will use a LangChain expression language to combine our prompt, our language model, and our vector store. So these are 3 pieces that we can combine using a specific language that LangChain has created called the LangChain expression language, which basically combines together these 3 components in a kind of a pipe structure. So you start with a question, then you combine it with a retriever, then your prompt, then your model, and then you get an output. But I will get back to this in a minute. First of all, we need to define our prompt. And for this, we will create a prompt template. So here we will set our template, and this template is used to give instructions to our model on how to behave. So we have scientific articles, so we want our model to behave as a scientist in immunology. And we want the model to use the context to reply to the question. And in this case, the context is actually the pieces of information that we retrieve from our vector store. This context will be a dynamic input, so is dependent on what pieces of text are retrieved from our vector store. And then on the next line, we will enter the question that we have received from the user. Again, LangChain has a very convenient module to create this chat prompt using the chat prompt template module. And here we insert our template. Then the second piece that we need is the model. For this, we will again use Bedrock. As I mentioned before, I like to use AWS to have all the LLMs combined in there. In the chat Bedrock module, we need to define a model ID. So in our case, we will use Anthropic's Cloud model version 3. And then we will define our Bedrock client, which we have created before. And here we can also provide some extra arguments for the model. So we will set here the temperature of the model to 0. Again, we will set our region to US East 1, because here are the most large language models available. So we have now our prompt and our model. Next thing that we need is our retriever. And for this, we will create a function that combines all the documents that we retrieve from our vector store into one document. And this is called the format docs function, which takes as an input all the documents that are retrieved by our vector store and then are joined into one piece of text by this join function. And finally, that brings us to our RAG chain, so our Retrieval-Augmented Generation chain, which is in the LangChain expression language that I mentioned before. So as you can see, this LangChain expression contains 4 components. First of all, here we have our vector store that we will call as a retriever. Then we have our prompt, which we defined here before, our model, which is defined here, and then this function, the string output parser, which takes the output as the model, which is generally a JSON output format, and only retains the answer that is formulated in the JSON structure, so that our chatbot only outputs that piece of information. So what does actually happen now when you invoke this LangChain? So with the invoke chain, you can insert here your question. And what happens then is that in the first step, the question is used to call our Vectorstore and to retrieve the relevant pieces of information in there. This is then piped to the format docs function, so all the pieces of information are sent to format docs, and there all the docs are merged into one text variable. And then this context together with the question are sent to the prompt. And if you recall here, there were two input variables required here, the context and the question, which is exactly what is passed from the LangChain into the prompt. And then this prompt is fed into the model, or Anthropic Claude 3 model. This is analyzed by the model and an output is returned. This output is sent into the string output parser, and only the text answer is retained from there. So if we now run all these pieces of code, so our prompt template, loading our model, then our chain, then we can invoke our chain. And if we wait for a couple of minutes, we will retrieve a response. So what happens now is all the steps that I mentioned before. We will go to our Vectorstore, find relevant pieces of information, put them into one text variable, together with a question, send it to the prompt. The prompt is sent to the model. The output of the model is parsed, and then we get this reply with it, which is a nice piece of text that is coming from our articles, but structured in a natural sounding way, like you are interacting with a real human. So that brings us to the end of this tutorial. We have learned how to build a custom AI chatbot that you can try yourself on your own data. This AI chatbot was built using LangChain, PineCone, and AWS Bedrock. If you like this content, please leave a thumbs up and subscribe to my channel. I also write tutorials and articles on Medium, so please go ahead and follow me there. You can also follow me on LinkedIn and Instagram. Thank you for watching and see you next time. Bye!